Good morning. Let us discuss a few more questions related to the equation of circle. Question is P minus 5 6, Q minus 3 8, R 3 2 are the points on a circle. Find the equation of circle. So we have 3 points on a circle which are P minus 5 6, Q minus 3 8 and R 3 2. Which are the points on the circle. So let us draw the diagram of this particular question. So on the diagram you can see there are 3 points on the circle which are P minus 5 6, Q minus 3 8 and R 3 2. Okay, we have to find the equation of circle. To find the equation of circle we require the center of circle and the radius. We required the center of the circle and the radius. So our first task is to find the center of the circle by using the concept the perpendicular bisectors of the chord. The perpendicular bisectors of the chords always pass through the center. The perpendicular bisectors of the chord pass through the center. Once again, the perpendicular bisectors of the chords always pass through the center of the circle by using that concept. So here suppose AB is a chord and this line represents its perpendicular bisector. And if you draw another chord, we can draw a separate chord, or else from this point itself we can join another chord. Okay, suppose I am drawing a chord here, let it be CD. And if you draw the perpendicular bisector of CD, both the perpendicular bisectors meet at a common point. Yes, that point is called the center of the circle. So you can draw number of perpendicular bisectors, doesn't matter. N number of perpendicular bisectors you draw for the chords, you can find out they all pass through a common point which is known as the center of the circle. So here our task is to find the perpendicular bisectors. That means to find the equation of perpendicular bisectors and solve those equations. So in our question here we can draw 2 perpendicular bisectors. Not only 2, we can draw 3. But let's make 2 perpendicular bisectors. One is the perpendicular bisector for PQ. That means let us draw the chord PQ and chord QR. So we have 2 chords here, PQ and QR. Now let's draw their perpendicular bisectors. The perpendicular bisector of PQ and the perpendicular bisector of QR. Okay, and you can see both of them pass through a common point. They meet at a common point. That point is C. Okay, so our first task is to calculate C. Okay, let's find the perpendicular bisector of PQ. Okay, so when we consider the term perpendicular bisector, here you can find 2 concepts. One is perpendicularity and the second one is bisects. Okay, the term perpendicularity we use to find the gradient. Remember, if 2 lines are perpendicular, then product of their gradients is -1. If two lines are perpendicular, then you have to remember the concepts that product of their gradients is -1. So with the help of this concept, we can find the gradient of perpendicular bisector. Okay, that point is the midpoint of PQ. See, the midpoint of PQ, this is the midpoint of PQ, which is a point on this line. Yes. So if you find the midpoint of PQ, that will be a point on the perpendicular bisector. So let's find the midpoint of PQ. So we are going to find midpoint of PQ. Midpoint of is x1 plus x2 by 2 and y1 plus y2 by 2. Okay, which is equal to x1 plus x2 by 2. x1 plus x2, that is -5 plus -3 by 2, and y1 plus y2 by 2, which is 6 plus 8 by 2. Yes, that is equal to -8 by 2, which is -4, and 14 by 2, which is 7. So midpoint of PQ is -4 and 7, which is a point on perpendicular bisector. Yes. So on the perpendicular bisector of PQ, we have a point -4, 7, and it has a gradient -1. So with the help of these two concepts, we can find the equation of this perpendicular bisector. So the point is -4, 7, and gradient is -1 for this perpendicular bisector. Just we are on the 10% of the problem, that's it. This perpendicular bisector. Okay, so equation of that perpendicular bisector is, what is the equation of a perpendicular bisector? Which is y minus y1 is equal to m of x minus x1. That is y minus 7. This y1 is this one, is equal to -1 of x minus -4. That is y minus 7 is equal to minus x minus into minus into minus, that is -4. That is y is equal to minus x minus 4 plus 7. That is y is equal to minus x plus 3. This is equation number 1. Now let's find the perpendicular bisector of QR. So same like the previous concept, as it is perpendicular, let's find the gradient of the perpendicular bisector. For that we have to find the gradient of QR. Which is y2 minus y1 by x2 minus x1. That is 2 minus 8 by 3 minus minus 3, which is equal to -6 divided by 6, that is -1. Therefore, gradient of perpendicular bisector M2 can be calculated by M1 into M2 is equal to -1, that is -1 into M2 is -1, or M2 is 1. Okay, now we have to use the term bisector, same like the previous steps. For that, find the midpoint of QR. Midpoint of QR, which is x1 plus x2 by 2, that is -3 plus 3 by 2, and y1 plus y2 by 2, that is 8 plus 2 by 2, that is equal to 0 and 5. So now we have to find the equation of that perpendicular bisector. Already we got the equation of first perpendicular bisector is y is equal to minus x plus 3. Now we have to find the equation of second perpendicular bisector. So the equation of perpendicular bisector is y minus y1 is equal to m of x minus x1. That is y minus 5 is equal to 1 of x minus 0. That is y minus 5 is equal to x, or y is equal to x plus 5 as second equation. Now we need to solve these two equations. So when we solve these two equations, we get the value of x and y. That will be the center. Okay. So to solve these two equations, you can use either elimination method or substitution method. Okay, we can use the convenient method. We get the answer for that. So I'm using elimination method. So let's add these two equations. We get y plus y as 2y is equal to minus x plus x get cancelled. 3 plus 5 is 8. So that we get y is equal to 8 divided by 2, which is 4. Now substitute the value of y is equal to 4 in any one of these equations. I'll substitute in equation 2, which is y is equal to x plus 5. We get, as we substitute y as 4, we get 4 is equal to x plus 5. When you transpose 5 to left side, we get x is equal to 4 minus 5, that is minus 1. So x is minus 1 and y is 4. Therefore, the center is minus 1, 4. So the center of the circle is minus 1, 4. We get this one as minus 1, 4. Now our next task is to find the radius of the circle. So to find the radius of the circle, let's take one point, either P, Q or R, any point you can take. So if I take P as the point, PC is called the radius, or QC is called the radius, or CR is the radius, anything. So now we have to find the length PC. So radius is same as the length of PC, which is square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared, which is equal to square root of x2 minus x1 the whole squared, that is minus 1 minus minus 5 the whole squared, plus y2 minus y1 the whole squared, that is 4 minus 6 the whole squared, which is equal to, under the root, minus 1 plus 5, minus 1 plus 5 is 4 squared, plus 4 minus 6 squared, that is minus 2 squared, which is equal to square root of 16 plus 4, that is square root of 20. So we got the radius as root 20 and the center as minus 1, 4. Now let's find the equation of circle. Equation of circle is x minus a the whole squared plus y minus b the whole squared is equal to r squared. It is x minus a is the x coordinate, minus 1 squared plus y minus b is 4 squared is equal to r, we got as root 20 squared. So we get the equation of circle as x plus 1 the whole squared plus y minus 4 the whole squared is equal to 20.